Nobody said anything about this, but it's related to my talk in some weird way. Whoever will guess will get soft skills for hackers or for the software developer's life manual. Sounds like an awesome book. Actually, I had 2 to give away, so yeah, you gotta keep you alive basically during the talk. That's the reason why we have this incentive. So it's a fig tree that grows in Australia somewhere, and what he's doing is slowly take over the host tree and kills it. It takes the sun away from the host tree. It uses the ground and takes the resources, the water, and just destroy it. It's pretty fascinating. So let's go to the beginning. Do I have 30 minutes or more, or how much? Just kick me out, basically, when I'm...
I'll kick you out.
Yep. So, Docker. Anybody here? I want to kind of assess that 30 minutes is not enough for anything, right? So I want to understand like what your kind of like experience with Docker. Can you raise your hand if you guys played with Docker before? Keep your hands up if you have Docker installed right now on your laptops. Okay. Did you run anything with Docker? Did you build something with Docker, even on development environment? I see 5 hands. 5.5 is scared, he's not sure. Anything on production? Ooh, okay. I have 3 guys on production. So you guys will help me, okay? Because Docker is so new that everybody is guessing. Nobody really knows what's going on. That's the truth. So I need your help, guys. And I don't know if it's going to be a discussion. 30 minutes is not really enough for a lot of discussions, but I'll be happy to answer questions if there are any. But I'll try to run as quick as I can to cover a lot of stuff. The goal is basically to give you a good introduction, like a 30,000 feet of what Docker, why it's awesome, and how it can change your life and your company's life, hopefully. That's me, Oren. That's my website, and that's my Twitter. I work for Sanguine. So basically, we save lives by accelerating and enhancing medical research. We use all kind of techniques. We're technology-driven. We're using these tools and platforms that have stuff like Uber-like, that we're dispatching nurses to people to donate blood and send them directly to the big pharmas that creating the research, conducting the research. This is just one of the things we're doing. We're doing a lot of awesome stuff, and we're hiring full-stack Node.js guys, JavaScript, Node.js, just awesome people in general. So contact me after my talk. We're going to have some drinks in a place nearby, which I can't remember the name. The other place? The other room, yeah. So if you guys want to get some drinks with us, join us. I have some swags to keep you awake. So every time you see the hungry little thingy over there, it means that like the question you can answer. What's your? Give me a stupid question to ask. What's the name of the book I'm going to give away?
Soft skills for developers.
There's so many people who raised. Whatever. Got it. That's how it works. So what is Docker? What does it solve? So we have like 4 big things that each one can be its own presentation. I'm not sure what to focus on. I'm just going to run with it and we'll see. So what it is, what does it solve, and how it helps you. There's 2 big things. One is in the development flow. The other one is the production flow. Anybody knows who the cat is? The cat, the white guy. This guy. What's the name? Who said Maru? I think 2 people, right? You're going to get this little bear here. And Concho for you. You know what Concho is? Google for it. Oh. Who's the bear person? Bear. So that's, you know the name of this cat? That's Maru's best friend. Come on. That's Hannah. So I'm going to get this guy. So basically, they're making more money than most of us on YouTube, like a few million views for each time. So containers are a way to, it's a tough one, to isolate your environment, to isolate your dependencies. So right now I have a project with like Nginx, with PHP, with Apache, with MySQL, with MongoDB, Node.js, a bunch of stuff. I just need Go and Java to like cover everything, right? And on my first day I was supposed to like run everything. I'm like, what? I'm not going to install PHP. It's disgusting, right? So what? Oops, some PHP guys. Sorry. So what do? Use Docker, and maybe show you just example of Docker. So So I have a bash script that I wrote, right? And all it's doing is launching like 7 containers on my laptop. Each container has the operating system itself. That's the idea of Docker, so it's isolated, and they know about each other, right? So I have bin, whatever, all run background. It's just a bash script, and you can see I put this nice green messages to tell me like what Docker is running, and you can connect. You can tell your Node.js, this is your MySQL, and this is your MongoDB, and they use it with the -- link, which maybe I'll show you, maybe not, but there's a way to do it basically. And it's every container has its own IP and port. That's why it's important to connect between them. Otherwise, how would my node know where my database is, right? And if I go to show you, it's running on my. I have like in my host file. I have like to change it to be laptop -donate, right? And this is PHP. Now it's actually Node.js, right? And I have nginx reverse proxy in a Docker container to do this stuff. And I have another inside the MySQL. I have like a little bash script to initialize it with the data that I need, the structure that I need. And the same containers, I'm going to throw them on production. So it's bit to bit, almost, between development and production, which is pretty cool. So let's just close it and just move on to the slides. But I get an idea of like how is it useful, right? I mean, I can take my containers that I have and just throw them on production environment or stage environment. So all the environments are just using the same bash script almost. There's a Walmart metaphor. Basically, the way that containers work, that's a little behind the scenes. I think I had a slide about. Oh, I skipped this guy. Everything here is on my website. You can see the slides, the code for the talk, and if you want to see that run locally, if you have Docker installed, just run this, docker run p. So this command, the second command, will just launch the presentation on port 3000 on your local machine. It will go to the Docker hub, that's a registry where all the Docker images are, grab it to your local machine, and run it. And internally, the Docker has port 80. You can have whatever port, but externally on your laptop, I want to map it to port 3000 because it's hard sometimes to run port 80 on my laptop. So that's a good example, like how to use Docker. You don't need to know what's inside. It might be running by node, this presentation slide. It's not. It's running nginx. It's a static JavaScript. But that's the beauty of it. In one command, as long as you have Docker installed, you have my slides running, right? So that's kind of like, that's why I don't want to focus too much on how it works and all those diagrams. You can, talk to me later on or just Google for this stuff, but at least you get an idea that it's awesome and you want to learn more. And some of you guys used Vagrant before or any kind of VM, and there's a few differences that Docker containers share the kernel with the laptop, with your host, or whatever host is going to be the production environment, right? So this sharing is great for I/O. It's very fast. It's minimal. It's just like a process. It's a special process. It's isolated in terms of like the mount system, file system, networking, but it's just a process, right? And it was around us for a long time, from the 70s, but nobody really built a nice API, except for this company called Docker, around it, and they open source it. So it's an open source standard that you can use. For developers, why it's awesome, I kind of explained to you why. Just very clean. My laptop is not cluttered with crazy environments and technologies I don't care about, and also can push the stuff to production in theory. And also for operations people, can deploy faster. The idea is that I think we all agree that we want to ship small pieces to production, tiny pieces possible, because by doing it we're minimizing the risk. And Docker, I think, is a good way to do this stuff, to achieve this tiny little things that are pushing to production. And I think that it will cause us to rely less on feature branches and branches in general. We don't need branches anymore. We put something, because every time we have a branch, you add some risk to your code, to your flow. So if you can just use everything on master and then small chunks constantly push into production multiple times a day, some of them might be like dark launch, which is okay, but at least if you can find a way to separate your release from the deployment. So you deploy constantly, but you don't release everything, and you can maybe switch on and off. It's called dark launch. So I think Docker is one of the elements that will help us deploy tiny little things to production constantly and minimizing risks. Let's skip this stuff. Well, there's something called an image, there's something called container. So an image is a template. So you have like a Docker file that describes the image, and the Docker file, you turn it with the build command into an image. And then with the run command, you turn an image into a container. Don't worry about it. It takes time to digest this stuff, but that's kind of the terminology. You can see that line number 2, it's the build command and turning a Docker file into an image, and then I'm running it in line number 4. That's not really important, but there's a Docker container, the Docker registry that you can push stuff to. It's public, doesn't cost anything, but it's private if you want to use it for your private stuff. You can also, with Docker run registry, you can in one command have it running on your own infrastructure on AWS or DigitalOcean. So you can run it yourself if you want to maintain it. You don't want to pay Docker. That's the ecosystem. There's a bunch of tools that people are creating. I'm going to show you the top one, which is the kind of workflow tools. So what is workflow? Heroku. Anybody doesn't know anything about Heroku? You guys all know what Heroku is? So there's tools that are replacing Heroku to put it on your data system. Why? Because Heroku sucks, or it's too expensive, or you just want to own it. So that's Deis and OpenShift. There's Mesos, Kubernetes. That's Google stuff, I think, Kubernetes, Marathon. And you can see that Docker, that's the level of containers, right? Docker, there's a competitor to Docker called Rocket. But Docker is the dominant right now. The Rocket guys are not happy with the direction of Docker, so they created their own standard, whatever. What does it solve? That's related to the fig tree, and you guys have 2 books to win. The Strangler Application is an architecture to deal with legacy code, especially with Monolith. Think of a code base that is very, very big, and it's one chunk of code. It's hard to maintain. So one approach is to use microservices. That's another thing that Docker helps, to create small little things that are together working. And they're replacing the old legacy code. So that's the fig tree that kind of wraps around the tree, and eventually it destroys the host tree. So that's kind of an approach for migrating away from Monolith. Using microservices that you can start from the nodes and slowly go up, which is kind of the opposite of what the tree is doing. But so yeah, anybody knows what Conway Law is? You got a book.
Structure of the software guy resembles a set of.
Can you pass it? So yeah, so Conway Law mean what Conway Law say is it's a different Conway from the computer science Conway, somebody else. That the social structure of your organization will be reflected on your structure of your code, which I kind of agree with. Like if you have like departments, like the ops guys are on a different floor, they're going to build their own stuff, and you need to like throw your stuff over the wall in order to push it to production. Or your QA team sitting somewhere else, and there's this barrier that we create in companies. And I think Docker is going to help to bridge the gap and create something similar to what Amazon are doing, which is a team that can own the stuff and push stuff to production as a team, instead of like having barriers. And you can see that bunch of charts of like how companies that look like. Microsoft is pretty funny. There's guns. Oracle has ton of lawyers. Apple is like one guy who's God. And that's when I came to Sanguine. That's what I saw. I'm like, interesting. What's going on here? It seems to me, and it was true, that some dude or a bunch of separate team built something totally separate, bypass everything, hit whatever Salesforce out there, just build castles, right? And I was right. So this dude was there and built some stuff for 3 months. After 3 months, he just pops out, bam, bang it, I'm done. So that's kind of Conway Law. The trick is to do inverse Conway Law, and that's what I have some links in my README about where it's coming from. But there's a technology radar. It's like ThoughtWorks are having like this crazy analysis about the market and what's the architecture and what's the tools to use in the coming years. So they say, hey, how about using microservices to structure your architecture that will reflect the social environment. So basically flipping it around. So by creating microservices, you will create an environment where people will be forced to work in such a way it will be way more productive. Maybe small teams, like Amazon has like 2 pizza size, just 10 people maximum, and they can own the stuff and push stuff to every environment that they need to. So that's the microservices approach and why it's awesome. That's other points that I want to talk about that I won't have time to, but it's related to CI and CD. Basically, CI is like building stuff after you do the testing, right? And continuous deployment is just deploying fast. Immutable infrastructure is something pretty cool. The idea is that when you push to production, you don't push and change existing servers. You create a set of new servers, mimic your production environment, and just point your load balancing to it. And if something is broken, you point it back. So you switch back and forth. And I think it's cool with Docker because now the unit of deployment is a Docker container as opposed to AMI if you're on Amazon, which is way faster and more efficient. And This guy works for Amazon. Steve Bezos hired him specifically to run around between the different microservices teams. And if you see that one team accesses the database of another service without the proper API, just directly, he goes and punch you with a fish in your face, bang his fist into the table and break your table and try to make you fired. Except for the fish and the breaking your table. Everything is true. He's trying to make you fired if you argue with him, and he makes sure that the services teams are separate, and so he's crazy. Who knows what Amazon are using for their desks, or it used to be?
Doors.
Who said doors? 2 people. Got a book here, and Hello Kitty candy you put it on your ring, I think, and then I don't know. It's weird. You on the book? You're not into Hello Kitty? Sorry, Hello Kitty?
Stereotype.
So yeah, and also something that the guy that says you build it, you run it. It's the CTO of Amazon. Basically, what he's saying that developers at Amazon are pissed because they have to take care of, understand how to run their stuff on production. I mean, I would be pissed too, right? It's kind of annoying. I want to develop stuff. I don't care about the logging stuff and monitoring stuff. That's for like ops guys. So no, Amazon, no, you got to take care of it. You own this stuff, and it's a good quote, and I love it. And in Google, for example, it's very different. Google have like people who care about like the making sure everything is running on production, and developers only care about their stuff. So it's 2 different approaches. I don't know which one is right. I like this one. I like the ownership. Development workflow. You guys know what yak shaving means? Nobody knows?
When you write code just to write code.
So when you do something that you gotta do, it's gonna add value to you, but not right away. It will add value later on down the road. So there's a bunch of like yak shaving that I facing every day. So this is one of them. So right now my laptop looks, actually it's more complex than this. This was diagrammed, I did it like a month ago. But on my laptop I have multiple containers. Each green box is a container. Actually there's a logging, there's another one for there's a few more. But they're communicating together. The database is also here, and they send everything, all the logs, to a separate system. And this is my logging. It's not done yet, but basically it's Heka, which is a tool, open source tool written in Go, built by Mozilla, that can accept both the etcd, which is application level logs, and also the logging, the regular logs from all your servers. So I'm streaming it away from this box and away from my laptop with the rsyslog, which is a Unix tool thingy built in every like Linux, into Heka, and Heka can move it back to Elasticsearch and then Grafana, whatever fancy graphs to display. But yeah, it's all Docker containers. It's all one bash script, which is. And this is another tool that I'm using. It's supposed to be here. There's 2 more containers, and this one called the Consul. It's on my README. You can see it. Basically, what it's doing is there's 2 tools, Consul and registration. And what happens is every time there's a new container running, it detects it, the registrator, and it pushes to this Consul. So Consul kind of like knows about all your services. So you can see I have multiple on my laptop right now, or on my dev box. And it actually works with like multiple hosts and stuff, but you need to kind of think of all the tools and build it yourself, which can be annoying, but that's one approach. I have another example for use case that I'm using is Cordova. I don't want to install Android. I don't want to install Ant. I don't want to install whatever I need to install or Cordova, all npm install. So I build a little Docker container, Docker image. You can look it up in the README, hopefully. If not, just talk to me. But in one command, I have Cordova running without actually the need to install anything, which is pretty cool. DevOps. So what you need to build your own like Docker on production? That's the question that I'm asking here. You have a scheduler, discovery service, and a registration, which I'll explain in the next few slides. Scheduler. So scheduler is something, is a component, right, that needs to receive an image and decide which of the available hosts to put it, right? Because you're not going to have only one host, you want multiple hosts, right? It's a distributed system. So that's what the scheduler is doing. So it needs a component to decide, and he knows, because he knows they depend on the scheduler. So there's different schedulers, but some of them are smart, some are round robin. But it's getting better, the whole scheduling stuff in different systems. Bunch of tools which we don't care right now. Consul I showed you earlier. There's another one for discovery. So discovery, basically, every time there's a Docker container, it tells the discovery service, hey, that's my IP, that's my port. and then the other services can ask the discovery with DNS or maybe with like a private network, depends. There's different ways to do it. Now, if you're going to choose the flow tool to do this stuff, the flow tool that you're going to use, which I'll show you one of them, called Deis, it will make all those choices for you, right? So that's kind of if you want to understand how to build it yourself and kind of you want to do it yourself kind of a thing. I just drew it an hour ago, but that's kind of like on the top you can see the CI flow that I'm planning to have, which is you push something, it goes to your CI server, the CI server run Docker build, run your test, and Docker push it to the registry, right? And then in the middle is the continuous delivery, so you run your deploy script and you have a deploy server somewhere, and then a deploy provision it with whatever tool you want. You can use Bash or Ansible or Chef or whatever you care, deploy to your environment. What is your environment? If you're on AWS, it might look something like this. That's something that I'm thinking of having, I'm building it right now, which is you have a region, you have two availability zones in the VPC. We have a load balancer that sends to both 1 and 3. And you want to be, if one is dead, you want the other to be alive, right? And every time you deploy to 2 and 4, right? That's a blue-green deployment or the immutable infrastructure. So you deploy to 2 and 4, and then if everything is fine, then you switch the load balance. And that's the Deis approach. In Deis, you can put 5, you have a cluster of 5, that's the minimum for production, the Deis recommends, and you put them on different availability zones. And that's it, you just send it to Deis. Deis take care of everything. You don't need to maintain all the load balancing, you don't need to do anything, basically. And I'll show you a demo of Deis. So that's Deis, that's the tool itself, which I got a few t-shirts from them, but they sent it yesterday from Colorado, so I don't have them. I'll just wear them every day or whatever. But that's Deis, that's like the way the flow. So you do git push, and it pushes to this controller guy, pushes to the internal Docker register, so you don't need to care about Docker registry. They take care of it for you. And then from there it goes to the scheduler. The scheduler decides on which of the hosts to put your container, and it communicates with this tool called etcd, which is a distributed configuration. It's a configuration file that can be distributed, and it's fault tolerance. The operating system that it uses for each of your minimum five hosts is CoreOS, which is a very lightweight Linux distro specifically for running Docker. And that's the users just go through the router. And it works with subdomains, so you can have like this presentation. If you go to docker.sanguinebio.com, it's a microservice running this presentation. Right? And that's the internal of Deis. Deis itself has about 10 Docker containers, which is kind of nice. They're using containers to build Deis itself. And they're all written in Go, and Docker itself is written in Go. And you can see here, use a developer, you have commands to run against the controller, and they have the schedulers, load balancer, that's the logging service. You can do Deis log -a your application. You can see all the logs from different hosts and stuff. And you can scale it very easily. So this is let's just try to run it myself instead of like trying it here. Let's go and do Deis apps. I have two apps. One is culture, one is Docker. It's a microservices, right? Let's do Deis scale. Let's scale the Docker or info dash. Let's see the Docker. How many instances I have running? I have 3. I want to scale to 1 because I don't want to spend 3 or whatever. Deis scale. CMD 1. And then I do -a probably. Docker. All right. So I'm just scaling up and down basically with Deis. So all I have to do is set up Deis on. I put on 3 Amazon instances, and now it's actually on DigitalOcean just to save some money. 3 instances just to test it. So yeah, I only have 1 now. Let's see that it's still running. I go to docker.sanguinebio.com. Here it is. That's the presentation. It's running. Okay. So yeah, that's about it. That's deploy a new version. First, you can do see releases. You see different versions. I wrote a little bash script, and I passed the bash script the version that I want. I want 008. Right? And that's it. That's how you deploy a new version to your microservice. That's it. Now you can see in the releases, you can see the new 008. Okay. We saw this. I don't know what this is. And Okay, guys. I get to talk about Angular in Angular.js meetup that Angular is dead and people throw stuff at me. But I think it's dying because virtual DOM framework's taking over. And check out Mithril.js. It's awesome. Huh? Virtual DOM frameworks, small micro virtual DOM frameworks that's mimicking, looking at Facebook, which is kind of annoying, and the learning curve is a little big, and they're taking the approach from Facebook, I think, and condensing them into the essentials, which is virtual DOM diff, and pretty much that's it.
You know what Angular 2 is doing though?
Angular 2 is, it's pretty crappy. just different type of crap. It's an opinion. It's just my opinion. I just don't want to deal with something that I need to constantly go to the documentation. I want to just get better at JavaScript and stuff. So, and that's it.